So let's write out our trig. We have so, ka, and toa. The reciprocals of sine is cosecant. What was the reciprocal of cosine? Secant. And tangent is the one that's kind of obvious, cotangent. And then let's go ahead and make our quadrants. On our quadrants, I want to mainly focus on the quadrantal. That means it is on the axes.
Good morning, teachers and subs.
So we have all students take calculus, and it's going in the order of the letter C. And if you're thinking, what do you mean by that? Letter C starts up here, goes around.
Thank you for your support. Have a great day.
Go Mustangs. All right. So at this point, would you agree the y value has to be 0? We didn't go up or down at all. Okay? Now, y'all know the word unit circle means 1 unit circle. It means everything's revolving around 1. So that means we went to the right one, did not go up or down, so it's 0. Let's go to our left then. On my left, did I go right or left? So it's going to be -1. Have I gone up or down?
No.
That is 0. Now let's go to the top quadrantal. Have I gone left or right on that one?
No.
So that's 0. And what's the y value?
1.
Boom. And on the bottom, what would the order pair of that one be? 0, -1. If you're like, okay, that was not bad, we're good. We can go up, down, left, right, okay? So now let's kind of do a little bit of a review from geometry. 30, 60, 90. How many is 30 degrees in radian mode? And I'll start you off with the pi over something.
6.
Pi over 6. Keep in mind, pi is equivalent to 180 degrees. So if I have pi over 6, that's 180 divided by 6 is 30. Okay? What about 60? Pi over how many? 3. And then pi over 2. Y'all knew. And then the ratios were, I don't use the x's, I just use the numbers in front of it. 1, √3, and 2. And it's kind of silly because it's mathematically incorrect, but I think about when I add the whole numbers, it goes inside the radical. In case you want to say radical 2 and 3 instead. Okay, just a way to check it. And then we have the other piece, which is 45, 45, 90. Let's write that on the bottom. So then, knowing pi is 180, 45 in radian mode has to be pi over 4, and then pi over 4 again, and pi over 2. What were the ratios of 45, 45, 90? Square root of 2 does come in. That's going to be at the end. 1, 1. Good. And the cool thing is, the dumb rule I kind of mentioned does work out for both. When I add the whole numbers, it goes inside the radical. Just a way to remember. Okay? All right. So then, if pi is 180, how many is 2 pi? 360. So in case you're thinking, well, what does that mean? This is 0 pi. And when I go all the way around, that ends up being 2 pi as well, because they are coterminals. So what would be over here then if I go halfway? Just 1 pi. So let's do the actual examples then. Make sure you're looking up at this as I go over the bottom. I'm not going to go back and forth. Okay? So on to A. The first thing we need to do is, where is tangent of pi over 3? Where's my pi over 3 going to lie in? Quad 1, 2, or 3? Or 4? 1, okay. So here's my pi over 3. Pi over 3 has to go right here. And when I complete my triangle, that tells me this reference angle is pi over 3. And if I were to look at my reminder, opposite of pi over 3 is radical 3. The hypotenuse, which is 90 degrees, has to be 2. Then that's going to force. The other side has to be how many? 1. So you know 2, you know the third one then, because we know the ratios. So tangent is what over what? Opposite over the adjacent. So we know opposite is the piece that's jumping from the reference angle. That's radical 3. Adjacent is not the hypotenuse, so it has to be 1. So given that we have that pi over 3, could you even answer this one as well without drawing in another one? Okay, so be clever about it. Let's move on to sine pi over 2. For sine pi over 2, isn't pi over 2 90 degrees? It's on the quadrantal, meaning on the axes, right? So if I were to draw this, pi over 2 is all the way up here, and that is a quadrantal. And that order pair is going to be what? 0, 1. And I'm going to teach it traditionally, and after today, I'm just going to jump to the final conclusion. Okay? And I will tell you what that basically means. Sine is opposite over hypotenuse. And just as a reminder, everything in quadrantal has hypotenuse of 1 no matter what. And the opposite is up and down movement. In this case, my up movement is 1. Adjacent is left to right movement. In this case, it is 0. Is everyone okay with that? So that tells me our opposite over hypotenuse here has to be 1 over 1, which is 1. So I'm going to add on to this. When given an order pair, x movement is cosine, y movement is sine. So let me go ahead and conclude what I mean by that. 0 is cosine of pi over 2. 1 is sine of pi over 2. What is sine of pi over 2? 1. So just by looking at the order pair, you know the sine is the x. Sine is not the x. Cosine is the x and sine is the y, and that's it. But if you want to take it traditionally, that's fine too. Okay? So let's go on to number 3b. On 3b, where would pi over 4 lie? Also first, because 45 degrees is from 0 to 90. So here I have pi over 4. So from this reference angle, my pi over 4 is 1 root 2. Everyone good with that? Cosecant is reciprocal of who? Sine. So if it's opposite over hypotenuse, it has to be hypotenuse over the opposite. So looking at the triangle, hypotenuse is what? Square root of 2. Opposite is? And done. If you want to drop the 1 on the bottom, that's okay. Everyone good with that one? Hopefully it's slowly coming back. Now let's go to the one that goes backwards. Tangent of negative 11 pi over 4. Where do I want to draw this? I'm going to go over here. I'm going to make it really big. All right. If we're going backwards because of the negative, instead of going around like the C, it's going to be the backwards C. Okay? So that's 0 pi. So if I go backwards, normally going forward would be, let's write out something. 2 pi is equivalent to, because of my denominator, isn't 2 pi the same thing as 8 pi over 2? Or 8 pi over 4? Yeah? So let's kind of think of it that way. This will be negative 11 or negative 8 pi over 4. Because I'm going the opposite direction, this is negative 4 pi over 4. Because we're going backwards. So if that's 0 pi and negative 4 pi, what is down here? Negative 2 pi over 4. So we're counting by negative 2's. 0, negative 2, negative 4. What goes up here? Negative 6 pi over 4. And does it make sense I have negative 8 over here? What is down here then? Negative 10 pi over 4. So we know 11 pi over 4 has to go where? In quadrant 3. So that's negative 11 pi over 4. I still want to write the other coterminal. That's going to be, is that negative 12 pi over 4? Is everyone good with that? So really, in the end, this triangle is representing the following. From negative 11 to negative 12, the reference angles are always positive. So we know that difference is pi over 4, which is going to give me 1 root 2. Now we have a problem. If you are in quadrant 3, didn't I go left and did I also go down? So these two must be negative as well. That's the only tricky part on non-quadrant ones. You have to decide on, is my x positive? Is my y positive? If not, put in a negative sign. Okay? So here I have tangent is opposite over the adjacent. So if tangent is opposite over adjacent, from this reference angle, what number is on the opposite? Negative 1 over. Adjacent is? Negative 1. And that's going to give us 1. And it looks like that's the only one that's a negative, right? So good for you guys. So when you see a negative, just go the other way around and add a negative and just count, okay? Now let's go to 2C. On 2C, do I need to go in circles again? I think we do. Oh, yes. What a fun class. Aren't y'all jealous? 12 pi over 6? Is everyone okay why 12 pi over 6 since that's representing 2 pi? So here's my 6 pi over 6. So what's going to go up here then? Between 0 to 6? 3 pi over 6. So 0, 3, 6, and then that's going to be 9. And then we already have 12. What's going to go up here? 15, thank you. Pi over 6. What's going to go right here? 18. Now it looks like I have enough, right? So where's 17 pi over 6 going to lie? Quadrant 2. So that's our 17 pi over 6. So between 17 to 16, the difference is 1 pi over 6. So what's on the opposite of pi over 6? 30 degrees has 1, and that is root 3, and that is 2. Which one has physical negative movement? The negative 3 went left. 1 went up. That's positive. So our tangent is opposite over adjacent. From the reference angle, my opposite is how many? 1. Adjacent is negative root 3. Is it normal to have a negative on the bottom when you have one fraction? What is a norm? On top. Does that mean I'm going to take off if you give me this? They're both the same thing, okay? But this will be the better answer. Kind of coming back a little bit. If it looks new, then we're going to just learn it all brand new. It's okay. All right, 3 pi over 4, without even looking at the, without drawing the quadrant, where would that one go? 3 pi over 4. 1? 2. It has to be 2 because 4 pi over 4 is going to be at 180. So let's go ahead and make it at 2. And we know that's 4 pi over 4. And that's 3 pi over 4. That makes it 45, 45, 90. So we have 1, 1, root 2. Which one has to give me a negative here?
Negative 1.
Negative 1 on the adjacent movement. Okay, so sine is what over what? Opposite over hypotenuse. So from this reference angle, when I jump, opposite is 1. Hypotenuse is radical 2. Should we rationalize this? Ideally, you should. So if I did it, that would give me radical 2 over 2. But to me, I'll take either or. Okay? And I would say if it were to be in an assessment, it'll say simplify all the way, which means I want you to rationalize. So let's go on the back. And we chose 4. That kind of seems scary. Not really. All right, 11 pi over 6. Is that going to go in a full rotation? No. Nope, because it's not 2 pi yet. So if it's not 2 pi yet, what quadrant? Quadrant 4, very good. So this is 0 pi, which is 12 pi over 6. And if we're looking at 11 pi over 6, that angle must be between these two, so pi over 6. So pi over 6 is radical 3. Do we see that it's on the bottom? It's on the bottom, negative. Then I have 1. Then I have 2. So sine is what over what? Oh, I made a mistake. Someone catch it. It should be 1. Because pi over 6 is what? 30 degrees. Sad day. So that should be negative 1. And that should be root 3. So we know sine is opposite over hypotenuse. So my opposite is -1. Hypotenuse is 2. Boom. For number 8, are we going in a full rotation at least? Yeah?
Yes.
So we know this is 0 pi. We also know that is 6 pi over 3. So we have to go one more, which has to be in quadrant 1. And we like quadrant 1. So difference between 7 to 6 is 1 pi over 3. That is radical 3. Down is 1 and 2. Are there any negative movements here? Nope. Secant is reciprocal of what? Cosine. And cosine is adjacent over hypotenuse. So I need to swap them.
Does hypotenuse or adjacent?
Hypotenuse over adjacent, correct. That would be. So my hypotenuse is 2, adjacent is 1, and leave it like that. Get rid of 1 if you want. Okay, last one for me to help you is the next one. Are we going all the way around?
Yes.
Once or twice?
Once.
At least once. So let's make that happen. So we have 0 pi, which is also 6 pi over 3. That makes it 3 pi over 3. I guess I'll just cut it in half right here. 1.5 pi over 3. So we have 0, 1.5, 3. What's down here? 4.5 pi over 3. 6 pi we already said. And then we need what? 7.5 pi over 3. If you're like, can we just write the whole numbers? That's fine too. As in, we can ignore these two, right? What's going to go over here then? 9 pi over 3. And then down here will be 10.5 pi over 3. So are we pretty much almost there? What quadrant do I need to draw this one in? In 3. So here's my 10 pi over 3. Between 9 to 10 is only 1 pi over 3. So we have radical 3, but what kind of radical 3 specifically? Negative. Then we have -1. Then I have 2. Cosecant is reciprocal of who? Sine. And sine is opposite over hypotenuse, so swap them. So my hypotenuse is 2. What's my opposite? Negative radical 3. Y'all remember rationalizing, or should I show that process just in case? Show it? Okay, rationalizing basically means when you have a radical on the bottom, that's considered improper. So you copy that on the top and the bottom. That's kind of like multiplying by 1, which doesn't change the value. So that will give me, I'm going to put the negative on top. -2 root 3 over, when I have two of the same radicals, they pop out because it is a perfect square. So this is good, but if I ask you to simplify all the way, this is a better answer right here.